Hi everyone and welcome to a new video of Web3 hacking and development tips. So in the previous video we talked that we are going to install a blockchain locally using Ganache, and we are going to deploy smart contracts and interact with them. Today I move it to another framework or development environment because Ganache it's not well maintained and oftenly maintained. So we are going to use hardhat, which is an Ethereum development environment, and we are going to install it. Just you have to go to hardhat.org, go to documentations, general overview, installations, and I will let you it's easy to install. Just you have to follow these steps to install hardhat, and then we will initiate a project and deploy simulate a blockchain locally, deploy our smart contract and interact with them using Python as usual. So I will let you do that, and we will proceed together after a while. So guys, here I'm in my Visual Studio Code. We are going to create a directory for our hardhat project. So let's do I'm gonna name it Python hardhat. We are going to cd to Python hardhat. And now we have to initialize a new hardhat project just by typing npx hardhat and let it do the job. So let's create a JavaScript project. Let's choose this path, then let's run it. Yes, won't get ignore. Do you want to install the sample project? Yes, we won't do that. We want to do that. And let's do its work. So guys, here we have initialized a new hardhat project, and now we are going to create a node. So let's do npx hardhat node, and this way we will be having a blockchain simulator on our machine. Let's give it some time. We will be receiving around 20 accounts, yes, 20 accounts or 19 accounts of wallets with their private keys. Each wallet contains almost 10,000 Ethereum. And if now we are going to move to Remix, we are going to deploy a contract locally on our hardhat simulator. So let's do that. So let's go to Remix. For example, I'm gonna take this. Let's take a challenge. This is, I think, we did this together last time. Let me see. Tracking vulnerable access control. For example, this smart contract that we developed together in the previous video. You can go and watch them, and then we have to compile vulnerable access. Just now we have to choose where you go here to dev hardhat provider. Okay, but I will show you something. So let's reload this. I'm going to reload it to start everything over again. So let's go and choose our smart contract to deploy. Let's say vulnerable access control. Let's compile it. Okay, now we have to go to hardhat provider. So this is our RPC endpoint that we are going to use to connect through it to the blockchain, to the locally installed blockchain. So it's 127.0.0.1 and the port is 8545. Let's press OK. And let's do deploy. So we have estimated gas fees. As we can see here, now we are receiving, because we are connected to our blockchain locally, so we receive it all the wallets that we have here. So if we go check F39, the first wallet 2992 92266. If we go to our project and the VS Visual Studio code, we're gonna see the same wallet here, F39 and 92266. So everything is working perfectly. So just we have to deploy our contract, and we will see that our contract is deployed on hardhat local blockchain. Let's do deploy. And now we have our contract deployed, the address. And if we go to our Visual Studio terminal, we're going to see that our contract is deployed with all the functions. Here we have the contract deployment. There is no name, but we have the address of the contract, the transaction hash, from which wallet, which is the first wallet. And now we can interact with our contract locally. So, and now what we are going to do, we are going to open folder, and we are going to, where is it? Just my users and documents, and where is it? Python hardhat, we named it, yes. And you select folder, and in this folder we are let's see if we still have our nodes. No. Okay, let's run it again, because npx hardhat node. Okay, npx hardhat. Now we are in our project. Let's open a new terminal. Let's do cmd, and let's, as usual, we create a Python vmv, let's say first hardhat project. Let's do the job. So our Python virtual environment is installed. Let's, as we did before, we do pip install. Let's first thing, let's activate our virtual environment. We do cd, then we do scripts, and then we do activate. And now we are in our virtual environment, Python virtual environment, inside a hardhat project. So let's do here we are in scripts, so back, and let's do another directory, and let's start coding. So guys, this is our contract, is deployed already, and on this address. And if we go and check our hardhat again, so where is our visual code? And we go here to node, and as we can see, this is our contract deployed at this address. Okay, transaction hash, from which wallet? The first wallet, which is our account. It contains 0 ETH, the gas used to deploy the contract, and the block number is 1. Okay, so we created the Python virtual environment inside our hardhat project. And now let's start coding. So we need to activate, we already activated our virtual environment. And now we are going to create a new Python file, which let's put it not in include, let's put here inside this. Let's call project. Let's name it challenge, because our contract named challenge. You can name it whatever you want, challenge.py. Let's start coding. So first thing first, you need to install Web3. So guys, Web3 library is installed, And let's interact with the contract manually through remix. So if we go here and we do, for example, get address, we have the address of the deployer, which is our first address. And if we go to our node, we can see that we have called this, it's an if call function. So we have called this the address through the address of the contract. And to make sure, for example, I have copy pasted what is it. So let's do this to make sure. So we called our owner address, the wallet address, from this contract. The address of the contract copied from remix, it's the same as here. So everything is working perfectly. So if you do another function, for example, here, let's say get owner balance. Okay, we're gonna see that the owner balance get balance, it's 0. Got owner balance, this is the function, it's 9999, which is the same here. If we go to our hardhat, we will be able to see the calls, all of the calls from our wallet to the smart contract. So now just we have to create our Python code to interact with this smart contract. So to do what we are going to do, it's the same as previous times, just from web3 import web3, and we need to connect to our node, which is the same as before, web3 again, HTTP provider, and this time our HTTP provider is HTTP our machine on the port 8545. So that's it. To connect to the blockchain locally, just we provide this RPC. And what we are going to do now, let's interact with our contract, which is deployed locally. So this contract, it has a receive function to receive Ethereum. I have no logic here, optional. You don't need anything to receive Ethereum, unless if you want to specify the amount to receive. Otherwise, here you can receive any amount of Ethereum. Here function, we have here a modifier to limit some functions to only the owner that can initiate these functions. We have also the constructor. Please see my previous video so you can understand everything, what is a constructor, what is a modifier, and this function receive. So here we have function change ownership. It takes address of the new owner, external owner. So because we have a modifier, we can remove this part. Does not require anything. The modifier does everything for us. Or we can keep it, because here, as I can see, it's it makes a check to avoid any mistake or address 0. Okay, for example, I said last time I said address 0 is a dead address, is this one. So if we put this address as an owner, the contract with all the funds are lost, because this address is a dead address and we cannot control it. So we have function withdraw, only the owner can withdraw the money, and the function get balance. Everything is okay. So let's interact with this smart contract using Python. We did that before, and I'm going to do that again, because now our contract is deployed locally in our local blockchain on our machine. So let's start. So what we are going to do, as usual, we are going to put the contract address. So let's say web3 to checksum address. And then we have our wallet contract wallet address, the wallet owner W3 to check some address. Okay. And we need the private key of our owner wallet. So what functions do we want to call? So let's get back to our contract on Remix. So here, first thing, we need to send some ETH. So we can do that by going here, choose the amount of ETH. Okay. And send some ETH. Press on transact, we'll be having ETH. So I will send 5 ETH from this contract and the other one, and another 5 ETH from the wallet through Python. So let's do transact, and our contract received 5 ETH. Now let's code it and receive it, and let's send some ETH through Python code. So let's finish our code. So we have here our contract address, wallet address, and our private key. So I showed you earlier, I sent some ETH using Remix, but now we are going to create a transaction. Okay, and we are going to send some Ethereum to the contract using Python. So let's start. So tx equal, let's create our transaction. So 2 is going to be to the contract address. Okay. Value let's do W3 to way. We want to send 5 Ethereum, so here we specify ETH for the unit, as we did before, gas that we are willing to spend, and for transaction we don't need too much gas, so let's put 50,000 gas. Okay. Gas price, let's do W3 to way, and let's put, like, for example, 0.1 G way. Okay, so guys, the G way is the unit it's the unit for the gas price. Okay, for example, we can put ETH here, for example. There is no problem in that, but you have to add multiple zeros here like this. So I don't know how many zeros. You can go check Ethereum units and you will see everything about Ethereum, Ether, G-Way, M-Way, and all the other units for the Ethereum network, and even Binance. So we need nonce to count the wallet transactions. So it's weth get transaction count from wallet address. Okay, what do we need? Also, we need the chain ID. So for the chain ID on our hardhat project, I could not find anything, so I went through some documentation on Google, and they say by default the chain ID of hardhat is 31337. So now we have our transaction. We created our transaction, so we have to sign it. Sign it. TX. Let's do W3 ETH account dot sign transaction. Let's do TX that we want to sign with what? With our private key. Okay. Let's now send the send signed. Let's name it send signed. Let's do W3 ETH. Sorry, send raw transaction. And we want to send our signed TX dot send dot dot raw transaction. So there is no mistake. So we can also get the hash of the transaction. Let's do, for example, print make it a bit to look fancy, like we type a message here, transaction hash, and we need a transaction hash, so let's do transaction hash space here. Then we do, it's our send transaction, so we need just we type send signed dot x. So normally everything is totally fine. We have our transaction, it's from this wallet. Value, we're gonna send 5 ETH. We are willing to spend 50,000 for the gas price 0.1 GWay. Nonce for the transaction count and the chain ID. Let's start and see. Let's see what it is going to give us. So what is the name of our, it's challenge.py. So we have the unit here, I have a mistake. So it's ether. Okay, let's try again. We have some mistakes here. Let me go through the. So yes, the error here, it says that the transaction gas price that I put here, okay, is too low for the next block, which has a base fee per gas, which is this number. So let me change it. So let me clear this. CLS. Let's do 0.6. Okay, and let's try again. Now we get our transaction. So this is our transaction. If we go to our node here, we can see normally our transaction. Where is it? Yeah, this is our transaction. We sent 5 ETH to the contract. This is the hash, the block. And the hash, the transaction hash, which is this one. Okay, let's do Control C. We go back to our CMD and let's print it next to it. Okay, and it is the same. Yes. So if we go and see our contract here, and we have received our 10 ETH. So what we did here in this video, we transferred ETH through remix, this function transact. Okay, and we did the same but through Python code, which is this code, and it's not that hard. It's easy to send transactions, especially in plain ETH, because for example, if you want to send USDT, we need to interact with the USDT contract, and we need one more thing that we are going to see in the future. Besides interacting with the USDT contract in our Python code, our smart contract should accept USDT. So there is some other code here, some other function that we have to add to let our contract accept USDT, to interact with USDT, so we can be able to withdraw USDT. So guys, this is all for today, for this video, and we are going to continue with our same contract in the next upcoming video. Thank you so much for watching.